whatever, okay, whatever the things we are going to discuss now, total the chapter I'm going to discuss with the help of the notes which is available, which is circulated to you. So that notes, so that it is easy to identify the answers for you also. So first I'll go for discussing about the total the notes, and later part we'll go for discussing about the question bank, the questions which is appeared in the question bank. Okay. In the last sessions, when I was discussing about the unit one, so that was consisting of the total overall picture of the conventional fuels as well as the non-conventional fuels. So we have seen the classifications and what is the disadvantages, advantages with the conventional fuels. Later on, we have seen the non-conventional fuels. All these things we have seen now in the last sessions, whatever we have discussed. Now let me go for seeing the unit two. In the unit two onwards, we are going to discuss about the non-conventional energies now, or non-renewable energy resources we are going to discuss. So we are going to have it many number of renewable energy resources which are available in our nature. So among all these things, we have the solar, wind part, biomass, biogas, as well as the ocean thermal, waves, and the hydrogen fuel cells. Many number of things are available with us. So among all these things, let us go for discussing one by one. See, today I'm going to discuss about the unit 2, which is deals with the solar energies first. Now, when I'm observing it, the solar energy part is concerned now. So if you are observing it carefully, the picture, whatever we are representing it here, see, so the foremost important things is the energy we are going to get it from the sun. Inside the sun, we are going to have the nuclear fusion reactions are going to be taken place. Because of that, lot amount of energy is liberating, and this energy is going to travel in the universe in the form of a lower wave energies. So you are going to have a two type of the wavelength energies. The energies with the two different wavelengths, one is a shorter wavelength, second one is a longer wavelength. So any energy or any wave which is having shorter wavelength is going to travel longer distances. Now, in opposite to that, if I have any wavelength, any energies is going to consisting of higher wavelengths is going to travel to a smaller distances now. So that is a way. Now, because of this particular things, we can able to conclude it. The energy, whatever we are receiving from the sun, is going to consisting of it's a shorter wavelength. Because of that, it is going to transfer to a longer distance. Now whatever the energy which is going to come, so certain amount of energy is going to fall on the earth surface straight away, and certain amount of energy is going to fall like other obstacles whatever we are going to have it. Now we are going to have it. Now we can have a doubt why we are going to see giving that much importance for the solar part. So you can find solar is going to be vastly available, no question of incurring any amount of money. Mm. So no question of pollutions it won't create. So many advantages are there now. At the same time, some disadvantages are also available with the solar, because I need to construct a panels, because these panels I need to keep it in a land. So which wherever I'm going to keep it on the land, so this land is going to be I can say that it's not going to be used at all now. You cannot use it further. So another one, the solar energies, wherever it is falling on the earth, it is not going to fall continuously with the same intensity at all. So at one place the intensity will be higher, and the second place the intensity may be lesser, this way. So whenever we are going to install a solar energy solar panels, we need to see where we are going to get it higher amount of energies. So there only we can go for keeping it this particular things now, this particular things, right? Okay, this way we are going to see the merits and demerits. Now, what challenges, if I want to use it, the solar energy's considerations now, what challenges I'm going to face? So the first and foremost challenge is initial cost, because I need to keep a lot number of solar panels now. Next, I need to see enough finance part is going to be there. When I want to incur lot amount of money, I'm going to say that more amount of finance will always be there. And just I just now I told you that it is going to consisting a certain amount of land is also needed for us. So because that land, whatever we are going to use it, is not going to be useful later part. So that was the major challenges what we are going to have it. So if any question appears like a challenges and remedies of the solar energies, you can write this answer straight away now. See, the radiation part is concerned now. I'm going to have a two type of radiations, especially because whenever we are going to start any solar power plant, first and foremost things, we need to install the solar panels now. So where to install? So we need to see now wherever you are going to have it, higher amount of solar radiation is coming, there you need to install it. Now when I want to identify the places, first and foremost things is I need to see, I need to measure, I need to estimate the solar radiation at a particular place. So first I need to estimate it now. So for the estimation process, this methodologies we are going to see now. So whenever I want to estimate it, I'm going to see how many types of radiations are available with us. See, two type of radiations generally. One is a extraterrestrial radiations and intraterrestrial radiations or terrestrial radiations. Intraterrestrial radiations or terrestrial radiations, both the words are same, but extraterrestrial radiation is another things. As the name indicates, extraterrestrial means the radiation which is available outside the earth's surface is called extraterrestrial radiations. Now this radiation is going to be lot amount, and now it is going to see that this amount of energies we can utilize it. And the energy whatever it is available in the extraterrestrial radiations is going to be in a smaller wavelength. Just now I told you, whenever the solar energy is to transfer or travel to a longer distance, so the wavelength should always be lesser, smaller wavelength traveling to a longer distances. That was a extraterrestrial radiation part. So when I'm saying that intraterrestrial or terrestrial radiation is concerned, the energies which are going to reflect from the earth's surface is called intraterrestrial radiations. Because just you can find one small example here. Assume it, the radiation whatever it is falling from the sun, straight away all the things which is falling on the earth's surface which is not reflecting at all, you consider that within the short amount of time the earth's surface is going to be gradually heated up, and the temperature on inside the earth is going to reach to 1000, 2000, 5000 degrees centigrade temperatures also. But what we are observing it, 99.99% of the energy whatever it is receiving from the earth, from the sun to the earth's surface is reflecting it back. But this reflection is not going to be in the form of a smaller wavelength. This reflection is going to be in a larger wavelength radiations. Because of this particular reason, this may not able to travel to a longer distances. That was the only differences. So a question is always going to be there from extraterrestrial and interterrestrial or terrestrial definitions. So please take care about this. This way you need to write. Now, whenever the solar radiation is falling on the Earth's surface, I'm going to find two type of things. One, the radiation straight away falling on the Earth's surface. The radiation so may not able to fall directly, because in between this you can able to expect certain amount of clouds. If clouds are there, the radiation will fall on the cloud, and from the clouds it is going to reflect to the Earth's surface. Now, this way you are going to have two type of radiations here. So the radiation which is straight away falling on the Earth's surface is called direct radiations or beam radiations, right? The second one, the radiation which is falling on the cloud and from where it is going to reflect on the Earth's surface is called diffused radiations. We are going to call that as a diffused radiations. Naturally, what happens? Certain amount of radiation has been absorbed by the clouds itself. So because of that, the diffused radiation is going to be lesser when we are comparing with the direct radiations. That's why now onto the Earth's surface, I'm going to find two type of radiations. One, straight away from the Earth, from the sun, directly it is falling on the Earth's surface. We call that as a beam radiations or direct radiations. The second one, it is going to fall on the cloud. From the cloud, it is going to fall onto the Earth's surface. So what I call indirect radiations or diffused radiations. Now on the earth surface, so two, one is a direct entering, second one is indirect entering. Now when I'm saying the total amount of radiation which is falling on the earth surface is nothing but the sum of these two things, what we call as a global radiation place. So you can find it here. Global radiation is the sum of these two things, direct radiations and diffuse radiations or beam radiations, right? So this is another very small things. Diffuse the tilted surfaces, how to go for calculating the angle. You can see the small derivation part here, which is going to come from the this particular figure, right? You can see, you can check it off, how it is going to be there straight away. Now after this, we are going to see that very importantly, measuring instruments here. Measuring instruments. When I'm talking about a measuring instruments, here first and foremost thing, solar measuring, solar radiation measurements is going to be done by a pyranometers. So this may be different type of pyranometers which are going to be available. One is the it's a pyranometer what you can able to observe it. Okay, so this is the one pyranometer. So if you are observing it carefully, so this is going to consisting of two type of tubes, inner tube and outer tube. And inside of the inner tube you are going to have a sensor here, which is going to sense the radiation which is falling on that, and which is going to convert that into the EMF place. So from where you can estimate how much amount of radiation that is falling on the surface. Now, first one, as the inner sensing element is going to be covered by the inner ring, and inner ring is going to be covered by the outer ring. Both the things. Now it is indicating whenever the radiation is falling on the outer ring, from the outer ring, the radiation is going to enter in and it is going to fall on the inner surfaces. From the inner surface, it is going to say that it is going to travel in and it is going to connect to the sensing elements from where you are going to measure it now. This is the way one we are going to have it. And of course, an additional parameters, additional instruments is also going to be there, because whenever I want to install, I want to keep this one on the surface, earth surface, I need to see that the earth surface is not going to be flat always. So it is going to have a certain amount of undulations now, certain amount of height differences. So what we need, whenever I'm keeping this instrument, I need to see that this is going to be flat. So for that, I need to adjust the length of the legs, whatever it is going to find. So additional components it's going to be provided for this particular things place. That was the thing what we can see now. Next, it is going to see that certain other instrument is it is going to be bimetallic parameter. So where we are going to see that it is going to consisting of whatever the things you have already studied in the thermocouples, how a thermocouple was working, which a combination of two different materials, which is going to consisting of different thermal conductivities here, right? That way. One more important thing is sunshine recorder here. So what about this sunshine recorder? This sunshine recorder is going to consisting of a globe type structure here. So below of that, you are going to find sunshine recording sheets. Now, on these sheets, you are going to have the graduations here. Nothing but the measurements it's going to consisting of. So, whenever we want to go for measuring the solar radiation, we are going to keep these particular things below the sunshine recorder or globe, and we are going to keep it under the sun. Naturally, you can see that whenever you are going to find the sun is rising from the east and it is going to move towards the west part. Now, gradually, what happens whenever the sun is in the east direction, the radiation, whatever it is going to fall like a inclination like this. Nothing but the radiation, it is going to fall in the inclined positions. And now, whenever it is falling on the globe, a glass bulb, and it is going to see that it's going to act like a, you can consider like a magnifying glass. If you are observing it the magnifying glasses carefully, if you can able to see concentrating the so solar radiation, you can able to burn it also. That much amount of concentration radiation it can be possible here. So here also this glass bulb is going to act like a magnifying glass. It is going to see that it is going to provide the solar radiation concentrating to a single point where it is going to start burning it now. That much higher amount of temperature is going to see. Now, gradually, when the sun is moving east to the west part, the radiation from the east side, west to west side is also going to be inclined position. Nothing but it is going to see that it moves from east to west. By the time the radiation is also going to fall on the bulb, and which is going to be concentrated. Because of that, you can able to see certain amount of burning will always be there on the sheets. Now, after at the evening part, we are going to check it now. We are going to check it. We are going to see burn it now. We are going to check how much amount of length it is going to be there. How much length? Now, after checking the length, you can see how much amount of radiation it is going to be fall on that. It can be able to measure it now. That is what we call it as a sunshine recorder here. So this is a sunshine paranometers. You can find it, which is also going to be similar. Now, thermal energy conversions here, major functions of thermal energy conversions, where we are going to see that what exactly the main aim of the conversions now. With the help of solar collector, what is the function of the solar collector? First, now the solar collector main function is to go for absorbing the solar radiation. That was the first one, or nothing but collecting of the solar radiations, right? The second one, it needs to go for converting that into heat. The second part. The third part, we are going to see that we are going to convert that into the electricity now. And after that, this electricity is going to be stored. So this is the four functions of the solar thermal energy conversions now. But among all these things, the first and foremost things is solar radiation collections is going to be important things now, right? So these radiations collections can be done by with the help of two type of collectors here. So one, you can find it non-concentrating type of collectors. Second one is a concentrated type of collectors. This question is there. So in the question bank itself, so you can see what is how we are going to classify the collectors, solar collectors. Solar collectors are going to be classified into two types. One is a concentrating type of collector. Second one is a non-concentrating type of collectors. Example for non-concentrating is flat plate collector. Concentrating type of collector, you can have different classification. So that we'll see it now. So in the flat plate collector, this is one of the very important question, please. Either flat plate collector or concentrating type of collector. One question will always be appear for you now. See, now in the flat plate collector, you are going to see that. So this is going to consisting of various components. One component is a container where all the components are going to be presenting. Next, it is going to consisting of glass covers whose main function is to go for transmitting the radiation to go in. But whenever I'm saying this transmission part is considered now, so wherever, whatever may be the component it is, 100% transmission is not at all possible for through any component here. If you are saying that 100% of radiation is falling on the glass cover, you always see that 70% to the 80% of the energy only it is going in, another 20 to 30% it is going out as reflecting it out. If more number of covers we are providing, more amount of reflections will always be there, and which is not going to be used at all. That phenomena of creating more number of glass covers is not useful. So maximum you can able to provide two glass covers which will be used. That's why in a flat plate collector, please remember, we are going to use a two type of covers, right? And another one, absorber here. So in the tank, wherever we are going to say that thermal insulation we are providing, and where we are going to have this particular absorber. What is the function of the absorber? Whose function is to go for absorbing the radiation which is coming through the glass covers. Now, most of the times for increasing the absorbability of the particular things, we are going to use it a black color coating now. Whenever we are going to use it black color coating, as you know that black color is going to have it higher absorbing capacities. What it is indicating? Higher absorbing capacities, it is going to absorb more amount of radiation. That is a one absorber. Tubes, of course, it is going to run the water passing through that. Insulation is another important component which is not going to allow the radiation, whatever it is collected by the absorber, to out. That was a major function of the insulation, whatever we are going to provide, right? A container, of course, you know that it is going to see that combination of all the components, whatever we are going to have it. Now, see, when we are going for this particular working phenomena here, whatever the radiation which is going to fall on the glass covers will enter through that, and it is going to fall on the surface of absorber, where it is going to see, it is going to absorb maximum amount of radiation and convert that into heat, and this heat can be utilized for generation of the steam, and from where you can able to generate the electricity. Now that was a major advantage of the flat plate collector, what we are going to find. Now if you are observing it, factors affecting the flat plate collector, now I'm going to find different number of factors. This is one of the important question place. See, number of glass covers, I told just now, I told you, if more number of glass covers are there, more amount of reflection will be there, so it is not going to be useful, so we need to have it minimum number. Now you'll see that wind speeds, wind speed, if the wind speed is increasing, naturally natural convection turns into the forced convection, and whatever the heat that is produced in the inside the glass covers is going to be taken out by the wind itself, so it is not going to be useful. So radiation absorbing emissivity, please. So black color coating, one of the another very very important, this question is there, how the temperature is going to affect the flat plate collector performance. Yes, temperature is always going to affect the performance of the flat plate collector. If the temperature is more, you can see that more amount of radiation will be falling on the surface, and it is going to have higher efficiencies. In a cloudy region, cloud cover, if it is there, clouds are there, nothing but where you can find the temperature is lesser. If temperature is less, you are going to see that it's not going to be that much useful here. So this question appears, so you can able to write it here. So where I'm going to atmospheric temperature is there, if higher temperatures, higher performance, lower temperature, lower performance. If clouds are there, where you can expect less amount of performance here. Now, when I'm considering the flat plate collector part, where the glass covers are flat, where I'm saying that glass covers are flat, whatever the radiation which is falling, and it is going to reflect it back. So the efficiency of the flat plate collector is lesser, where you cannot go for reducing the temperature more than 100. Maximum 90 degrees centigrade temperature you can able to achieve it, but less than that only we are going to use it. That's why the applications of the flat plate collector is going to be lesser, where you can see that the major applications of the flat plate collector is going to be like a water heating for your household applications, or for a heating process where we are going to use it for industrial applications like a pickle industries or something else, that it can be done, only that. But whereas if I go for concentrating type of collector, where all the radiation is going to concentrate to a single place, where you can able to achieve it very higher amount of temperatures here. So the applications of these particular things is also going to be enormous. That what we are going to see. How we are going to classify this? Three type of classifications it can be done: parabolic trough system, parabolic dish system, power tower system. And what you can able to measure it, you can able to see how it is going to be advantageous here. Now, in each and every case, you can see one of the important things is applications. This is another. Most of the times, this one question is going to appear from the applications. We are going to have it lot number of applications. One is water heating system. If you are observing it carefully, if you learned one, you can answer all the things, because all the things it is going to be more or less same, right? If you are observing it carefully, water heating system, where I'm going to find two type of circuits here. One is a primary circuit which will is connected to your solar panel. The secondary circuit where we are going to connect to the applications. So in the primary circuit, we are going to run a separate fluid which is going to connect to the solar panels, which is we are going to connect to the solar panel. Whenever it is connecting to the solar panel, naturally the fluid whatever it is going to pass through that, it is going to be heated up, and this heat is going to be given to the second circuit, and the maximum temperature what we can able to achieve it is not going to be more than 90 degrees centigrade. That's why this application we are going to use it especially for household applications for a heating of the water. Or else you can see that this application we are going to use it for heating of the pickle industries, where we are going to clean the complete mangoes, all these things, and remove, clean it. For that particular case, here we are going to use it here, right? Solar water heating system. Now coming back to space heating system, the operation is going to be same, but application is going to be different. So if you are using for taking bath, you can say that water heating is needed. If you want to see that, if you want to send the same thing to heat a room, you'll say that that is going to be different, that is going to be slightly different. Okay, so this is another one. Refrigeration system is another very important thing. Nowadays we are going to have it in our houses. We are going to have the refrigeration systems, freezers. But whereas if you are observing it carefully, so all these things is going to be operated by the electricals. Now whereas if I see that electrical operations is going to take place here, so more amount of current bills will be there. So in order to avoid that, in order to check it here, we are going to use it, the solar refrigeration system here. So this also going to consisting of two type of circuits. One circuit will be connected to the solar collector. The second circuit is going to be connected to what we call intermediate circuit. And the third circuit is going to be an application circuit here, right? You can see that picture here straight away, you can find. But only one important things one has to remember. And another application is desalination system. Especially this desalination system is going to be more advantageous wherever water scarcity is available now. Water scarcity is available, one. Number two, wherever you are going to have it, water, salt water is there, and where you can go for converting the salt water into the potable water, drinking water. Especially in the sea coastal areas where they are going to have it only the salt water. But whereas if they are saying that only salt water is consisting, they cannot able to drink it. They need water, drinkable water. So for converting of that, we normally use a desalination system. Nothing but, as the name indicates, salination means salt. Desalination means removing of the salt with the help of the solar. So that's what we call solar desalination systems. So this, it can be done in a two different methodologies. One is a active process and second one is a passive methodologies. But whereas you can find it commonly, you will say that it is going to be done with the help of only solar cells. See, observe it carefully, where how it is going to work. Here, this is going to consisting of a separate container here. Inside the container, we are going to keep it the salt water, and outside of that, it is going to collect. It's going to have the solar the glass covers, which is going to allow the radiation to go in. Just now we have seen it. When I'm going for a flat plate collector, you are going to find it needs always two covers. So here also we are going to provide the two covers here. So first radiation, whatever it is falling on that, it is going to enter in and make the salt water to evaporate now. Now when salt water is heated up, the water is going to be evaporated, and at the same time, the salt is going to be remained here. The salt is going to remain in at the bottom. Salt is going to be remained at the bottom, and only the water is going to be evaporated now. When the water is evaporating, and this water vapor is going to going up, and it is going to stick to the second glass covers here, and where it is going to be condensed and converted that into the water content, and it is going to come down and it is going to be collected here. So this is the working of the solar panels here. One more application, very important application, what we can find is the solar pond. Solar pond here. Okay, solar pond. This is another important thing. If you are observing it, this question many number of times this question is appearing. Solar pond. Solar pond here. Solar pond is a one where we are going to see this. The complete pond is going to be mixed with the salt water. Now, if you are seeing that this salt content inside the water is gradually increasing, salt content gradually it is increasing, salt content is gradually increasing here. See here, this when we are observing it carefully, the solar pond here, we are going to see the bottommost portion where it is going to consisting of higher amount of salinity content. So whenever we are going to find high salinity content, it is having higher ability of storing of the energies, where the higher amount of temperatures is possible at the bottom side. When I'm saying that higher amount of temperatures is possible, it is used for increasing or converting that into steam, and that steam can be expanded in the turbines. That is possible here with the help of the solar panel, solar ponds, right? See, photovoltaic cells, as you know that very well, photovoltaic cells, how it is going to operate with the negative and positive cells, what it is going to see, bands, a certain amount of applications here. Okay, these are the. So here now we'll see the question bank. What are the questions which is appearing here? See the question bank. See the questions which is appearing for you many number of times. See all of you. See 2 marks questions. List out various types of solar energy collectors. Just now we discussed. So we are going to have two type of collectors. One is of a non-concentrating type, and second one is a concentrating type. So under the concentrating type, you can classify it like a parabolic trough, parabolic dish collectors, and power tower systems that way. So temperature effect, just now I told you about the temperature effect, how it is going to affect. Extraterrestrial, terrestrial radiations I discussed, and how concentrating collectors is different from flat plate collectors. So you need to have a tabular column, please. Whenever we are going to find the differences, you need to find. This is a 2 marks question, two differences you can able to write it. So brief about the solar radiation, we have seen it. The second question, challenges and remedies. That question is available in your notes. And the B bit, say third question, solar radiation measuring instruments. So we are going to have a different number of solar radiation measuring instruments, pyranometers, we have sunshine recorders, we have pelletolometers, we have so many things. So but among all these things, you need to write the names, as well as that you need to mention, you need to mention it, you need to mention it sunshine recorder. You need to write about the sunshine recorder here, please. See now another fourth question, how to convert saline water into potable water. Just it is an application, desalination system. So please remember, this is a desalination. See desalination. See desalination systems that you need to have. So once again, pelletolometer is a solar radiation measuring instruments. Solar water heating is an application. Just we have seen evacuated tube is also there, applications. Concentrating type of collectors, seventh question, concentrating type of collectors classifications. So three type of classification, parabolic trough system, parabolic dish system, as well as a power tower system. You need to write completely about that. And solar pond, one more question they have given. Ninth question, photovoltaic cells. This is also available in your notes. Solar desalination. Now the two same questions, it is appeared previously and now. So the same question it is there, but two different way of asking the questions. So please take care about that. And now applications of the solar photovoltaic cells, that it is given. And now what are the factors which affects the solar flat plate collector? Just now we have discussed about different factors. One maybe of solar glass covers, atmospheric temperature, cloud covers, absorbability capacities, wind speeds, all these things we have discussed, and all these things comes under this category here, please. Okay. So please, this is about the second unit, whatever we have discussed today. And now in the next sessions, I'm going to discuss about the third unit and third and fourth, fifth, the complete things I'm going to discuss today. Right in the next sessions, whenever we are going to have it. So this question, these things we are going to discuss, so in the next sessions, so in the next class I'm going to discuss about this particular things, please. Okay. If you have any doubts regarding these particular things, I am ready to answer you. So in the last sessions itself, I have given already the material and everything for you, the second unit, third unit, and fourth unit. If material is not available with you, please let me see. Please, I'm requesting you one. So whenever I have given the material, please go through the question bank. Keep your question bank material side by side, and please cross check it once. All the questions, whether it is available, all the questions answers, whether it is available in the notes or not, please cross check it. If the notes are not available, let me call it, please. So I'm going to supply the material which is not available with you now. So certain amount of things, if it is not available inside of that, so that is intentionally I might have already given it. Why I have given intentionally, something you yourself need to answer it. So if you are not able to get that, so please let me know about that. I'm going to supply the material for you now. Please, I request, keep your question bank and the material side by side. Cross check each and every question. Now also